Imagine standing at a silent crime scene where no witness is speaking, no suspect is confessing, and yet the truth is already present. Hidden in plain sight, this is where the principles of forensic science begin. Because forensic science is not about guesswork or drama. It is about understanding that every action leaves a trace and every trace tells a story, if you know how to read it. And the foundation of this entire discipline rests on a set of core principles that guide investigators from chaos to clarity. Starting with the principle of individuality, which states that no two objects, persons, or events are exactly alike, meaning that a fingerprint, a DNA profile, a handwriting sample, a shoe impression, or even a fracture pattern on broken glass carries unique characteristics that can be traced back to a single source. And, for example, when investigators recover a fingerprint from a glass at a burglary scene and match it to a suspect, they are relying on the fact that the ridge patterns on human fingers are unique and permanent, forming before birth and remaining unchanged throughout life, making this principle the backbone of personal identification, followed closely by the principle of exchange, famously introduced by Edmund Locard, which explains that whenever two objects come into contact, there is a mutual exchange of material, meaning the criminal leaves something behind and takes something away, whether it is fibers, hair, soil, paint, blood, or gunshot residue. A simple example would be a hit-and-run case, where tiny paint chips from a vehicle are found on the victim's clothing, allowing forensic analysts to trace the exact make, model, and sometimes even the year of the car, involved proving that even the smallest particles can become powerful witnesses in court. Spells. And then comes the principle of divisible matter, which teaches that matter can break into smaller pieces, while still retaining the properties of the original object, such as when a torn document, broken glass, or cut fabric can be physically or chemically matched back to its source. And in real investigations, fractured glass from a crime scene can be reconstructed like a puzzle to determine the direction of force, or whether a window was broken from the inside or outside, which can completely change the narrative of a case. And equally important is the principle of comparison, which emphasizes that unknown evidence must always be compared with a known standard to establish identity or association. Because without a reference point, evidence has no meaning, and for instance, a bullet recovered from a crime scene must be compared with test bullets fired from a suspect's weapon under controlled conditions to determine whether they share the same microscopic striations. 3. Ensuring that conclusions are based on scientific comparison rather than assumptions. While the principle of analysis reminds us that the methods used to examine evidence must be scientific validated and performed by trained experts using proper instruments, because improper handling or unscientific techniques can contaminate or destroy evidence, which is why forensic laboratories follow strict protocols, chain of custody rules, and quality control measures, ensuring that every test result can withstand scrutiny in a court of law. And alongside this stands the principle of probability, which acknowledges that forensic conclusions are often expressed in terms of likelihood rather than absolute certainty, especially in areas like DNA analysis, where experts may state that the probability of a random match is 1 in several billion, helping judges and juries understand the strength of the evidence without exaggeration. While the principle of progressive change teaches that evidence changes over time due to environmental factors such as heat, moisture, bacteria, or human interference, meaning blood dries, bodies decompose, tire tracks fade, and digital data can be altered or deleted, which is why timely evidence collection is critical. And a delayed response can mean losing crucial information forever. And another crucial idea is the principle of cause and effect, which explains that every criminal act produces specific results that can be scientifically interpreted, such as the pattern of bloodstains, revealing whether a victim was standing, sitting, or lying down at the time of attack, or the nature of wounds indicating the type of weapon used, allowing forensic experts to reconstruct events step by step, transforming scattered clues into a logical sequence. And all these principles operate together under the principle of reconstruction, which is the ultimate goal of forensic science, to recreate the events of a crime based on physical evidence, witness statements, and scientific analysis. Not to speculate, but to scientifically rebuild what happened, when it happened, how it happened, and sometimes even why it happened. A powerful real-world example of this can be seen in cold cases, where decades-old evidence is re-examined using modern DNA technology, leading to the identification of offenders long after the crime occurred, proving that forensic science does not forget it, waits, and as technology advances, these principles remain constant even as tools evolve. Whether the evidence is biological, physical, chemical, or digital, and the strength of forensic science lies not in television dramatization but in disciplined observation, careful documentation, and respect for scientific method, because one mistake in evidence handling can lead to wrongful conviction or allow a guilty person to walk free, making ethical responsibility a silent but essential principle that every forensic professional must uphold. And as we reach the end of this discussion, understand this: clearly, forensic science is not magic. It is patience, precision, and principle. It is the art of listening to what evidence whispers rather than forcing it to shout. And in a world where lies can be spoken and memories can fade, physical evidence remains honest, waiting for those who know its language. So the next time you hear about a crime being solved through forensic evidence, remember that behind that solution stands a powerful framework of principles guiding every decision, every test, and every conclusion, reminding us that science, when applied correctly, does more than solve crimes. It protects the innocent, exposes the guilty, and upholds justice itself.